we continue our discussion. Complex numbers, complex theory. We will be explaining simple problems for the time. Then afterwards, we will move to IIT level. And let us see the sum, difference, product, quotient of two complex numbers. Now here you consider Z1 is x1 plus iy1, Z2 is x2 plus iy2, Z1 plus Z2. Now we have to add the real parts x1 plus x2 plus I into y1 plus y2. Now this is how you define the sum of two complex numbers. Now we take the sum of the real parts, we take the sum of the imaginary parts, and we have the formula x1 plus x2 plus I into y1 plus y2. Now Z1 minus Z2. It is x1 minus x2 because that minus sign comes. So x1 minus x2 plus I into y1 minus y2. Now Z1 into Z2 is different. You can see x1 plus iy1 into x2 plus iy2. x1, x2 is coming. iy1 into iy2. So I squared y1, y2 minus y1, y2. So the real part is x1, x2 minus y1, y2. Now plus this I will go with the imaginary part. Here you can see x1 multiplied by iy2, x1 multiplied by iy2, and x2 multiplied by iy1. So plus I into x1 y2 plus x2 y1. So this is the real part of the product Z1 into Z2. You can see the real part contains the product of the real parts, then minus the product of the imaginary parts. So this is how you will explain the real part of the product. Now Z1 by Z2 quotient x1 plus iy1 by x2 plus iy2. Now whenever you have a complex number in the denominator, you have to multiply by its conjugate. So x2 plus iy2 conjugate is x2 minus iy2. You multiply numerator and denominator. Now you can see x2 plus iy2 into x2 minus iy2 is x2 squared minus I squared y2 squared. Minus I squared is plus 1. So it is x2 squared plus y2 squared. And you can see the numerator x1, x2 is coming. Then iy1 into minus iy2. Minus I squared is plus 1 y1 y2. Now x1 with minus iy2, x2 with iy1 produces I into x2 y1 minus x1 y2. So this is how you explain the quotient of two complex numbers. Always remember, whenever there is a complex number in the denominator, you multiply by the conjugate. Okay, now we consider examples. 1. Simplify. I raised to 21 plus 1 by I raised to 22, the whole raised to 4. Now we see I raised to 21 is I raised to 20 plus 1. And multiple of 4 will balance, it is only 1. So it is I raised to 1, which is I. I raised to 22 is I raised to 20 plus 2. So this reduces to 1. And then I squared is minus 1. So I raised to 21 plus 1 by I raised to 22, the whole raised to 4, is simply I minus 1, the whole raised to 4. Now this is important. 1 minus I, the whole squared, reduces to 1 minus 2I, then plus I squared is minus 1. So it is actually minus 2I. And 1 plus I, the whole squared, is 1 plus 2I plus I squared is minus 1. So it is always 2I. So remember, 1 minus I the whole squared is minus 2I. 1 plus I the whole squared is plus 2I. So I minus 1 the whole raised to 4 is same as 1 minus I the whole raised to 4, which is 1 minus I the whole squared. So it is minus 2I the whole raised to 2. Minus 2I the whole raised to 2, because 1 minus I the whole squared is minus 2I. So minus square is plus. 2 squared is 4. I squared is minus 1. So net effect is minus 4. Minus will balance, but I squared will continue with a minus. So 2 into 2 is 4, with minus 1 is minus 4. So this is the final answer. Another example. If x plus iy the whole cube is u plus iv, show that u by x plus v by y is 4 into x squared minus y squared. Now we apply binomial expansion. U plus iv is x plus iy the whole cube. So it produces s cube plus 3x squared into iy plus 3x into iy the whole square plus iy the whole cube. It reduces to s cube, then I squared is minus 1, so minus 3xy squared plus I multiplied by 3x squared y, and I cube is minus I multiplied by y cube. So net effect s cube minus 3xy squared plus I into 3x squared y minus y cube. So u is the real part, it is s cube minus 3xy squared. V is the imaginary part, which is 3x squared y minus y cube. So the problem is u divided by x. So you have to divide by x. When you divide by x, it becomes x squared minus 3y squared. And when you divide this by y, it becomes 3x squared minus y squared. And when you add these two, x squared plus 3x squared is 4x squared, minus 3y squared minus y squared is minus 4y squared. So net effect, u by x plus v by y is 4 into x squared minus y squared. So try to analyze questions like this. Now we consider an important example. If I into z cube plus z square minus z plus I equals 0, then what is modulus of z? Now here we collect the terms and simplify. Now you can see z square is common in these two terms. So we take z square out. Z square into iz plus 1. Now this minus 1 is I squared. So this is actually I squared z plus I. So we see I is common factor. So when you take I outside, it becomes iz plus 1. So this is also iz plus 1. So the result comes as iz plus 1 multiplied by z square plus I equal to 0. That means either this is 0 or that is 0. That becomes z is minus 1 by I. Minus 1 is I squared, so it is simply I. Here it becomes z squared is minus I. Now the problem is modulus. So we go to the modulus. Modulus of z is modulus of I, and you know modulus of I is 1. Modulus of z square is modulus of minus I. That is also 1. So modulus of z square is actually modulus z the whole square, which is 1. Therefore modulus z is 1. So in this case, modulus z is 1. In that case, modulus z is 1. Answer, modulus z is 1. Now we come to the conclusion of this lesson. For the time being, we will be dealing with only the preliminary fundamental ideas of complex numbers. We will go to the deeper levels later. I would like to ask you to convey this message to your friends so that many will be benefited. Now in our next lesson, we will be discussing limits and continuity of calculus. So let us see. You enjoy it. Best of luck for all of you. Thank you.